All right, so free response number one.
Oh, am I in the video now?
Yeah.
Nice.
A 3 microfarad parallel plate capacitor is connected to an 11-volt battery. Question A asks us for the charge on each plate of the capacitor. Question B asks us for how much energy is stored. Part A, capacitance equals Q over V. Capacitance is the measured in farads, and we are looking for Q, which is charge. So we are just going to write 3 times 10 to the negative 6th equals Q divided by 11. Some very, very straightforward math will tell us that the answer is, it's going to be 3 times 10 to the negative 6th times 11. The answer is 3.3 times 10 to the negative 5. Confirmed? Answer 1A, 3.3 times 10 to the negative 5.
1A just says 33.
Yes. Oh, it's
It says 33 microcoulombs. So 33 microcoulombs is 3.3 times, it's 33 times 10 to the negative 6, which is the same as 3.3 times 10 to the negative 5. So that is in fact the correct answer.
You're right.
Moving on. So
What is the energy?
B is asking for how much energy is stored. The equation for energy is 1/2 QV squared, I believe. Let me just check that.
I say, what is
It is, yeah, so potential energy is 1/2 CV squared, my bad. So the potential energy is 1/2 times CV squared. C, we already established, is 3 times 10 to the negative 6. So it's 1.5 times 10 to the negative 6 times 11 squared. Doing some, again, very basic math is going to lead us to the answer that 1.5 times 10 to the negative 6th multiplied by 11 squared is 1.85 times 10 to the negative 4th joules.
1.1 times 5. Yeah.
Yes, that's
Same thing.
That does make sense.
Wait, 1 point what?
181.5.
Yeah, 181.5. Time, wait, 181.5 to
Whoa.
181.5 UJ.
U. Okay, fine. That's the unit thing.
Yeah.
The answer is 1.815 times 10 to the negative 4th joules.
I'm just following the answer.
That is the correct answer. Gentlemen, please be quiet. A parallel plate capacitor has an area of 2 times 10 to the negative 4th meters and is separated by 3 millimeters. The capacitor is connected to a 9-volt battery. Find the value of its capacitance. The capacitance for part A equals the permeability of free space times A over D. The permeability of free space is, yikes, 8.85 times 10 to the negative 12th. The area, we were just told, is 2 times 10 to the negative 4th. The distance is 3 millimeters. That's 3 times 10 to the negative 3. So we're going to take our thing over here. We're going to do 8.85 times 10 to the negative 12th times 2 times 10 to the negative 4th. And then we're going to divide by 3 times 10 to the negative 3rd. 5.9 times 10 to the negative 13.
Correct.
5.9 times 10 to the negative 13 is the capacitance. C equals 5.9 times 10 to the negative 13th farads. B, what is the charge in the capacitor? So the charge on the capacitor we're going to find by doing the capacitance equals Q over V. So 5.9 times 10 to the negative 13th is we're just going to multiply by V to get our answer. So we're going to take our answer, we're going to multiply by 9, and we're going to get Q equal to 5.31 times 10 to the negative 12th. Good?
Mm-hmm.
Moving on. Number 3, a potential, let's scroll down to their answers. We'll keep it over here. A potential difference of 5 volts is maintained across a 50 ohm resistor for a period of 80 seconds. What is the total charge that passes by a point in one of those wires connected to a resistor in this time interval? So we need to find I and then use I to find Q. V equals IR. So V is 5 and R is 50. I is going to be 0.1. You could just do 5 divided by 50 is going to be 0.1. I, in additional to being equal to V equals IR, I equals Q divided by T. So since we know that T is 80 in this particular case, we're just going to multiply our answer by 80 to find Q, which is going to be 8. So Q in this particular case is going to be 8 coulombs.
Correct.
Moving on. 3 resistors are connected across the circuit in the figure shown below. What is the equivalent resistance of the circuit? And what is the current flowing from the battery? So part A, in order to find the equivalent resistance, we need to do 2 steps. First, we need to combine resistor number 3 and resistor number 6 so that the combination will be in series with resistor number 4. Then we can just add it to resistor number 4. So in order to combine resistor number 3 and number 6, we need to take advantage of the fact that they are parallel. The equivalent resistance of resistors in parallel can be found by doing 1 over Req equals 1 over 6 plus 1 over 3. 1 over 6 plus 1 over, so 1 over 3 is 3 over 6. So the answer is 4 over 6. Therefore, Req equals 6 over 4 or 1.5. Req equals 1.5, so that means we can get rid of these two and pretend it's one giant resistor with resistance of 1.5, which means that the equivalent resistance is going to be 1.5 plus 4, which equals that the equivalent resistance is 5.5.
It says 6.
I made a mistake. Where is my mistake?
Can it be rounding?
I made a mistake. Yeah, I see where my mistake was. My mistake was the following. I did math poorly, which is why you should always use a calculator. 1 over 6 plus 1 over 3 is 1 over 6 plus 2 over 6, which equals 3 over 6, which means Req is 2, which means that the answer is 2 plus 4.
Ah, there we go.
And therefore you get an answer of 6. That
Yep.
is a math error on my part. Req equals 6. Since Req equals 6, we can use the equivalent resistance to find the current flowing from the battery because V equals IR. 24 equals I times 6, which means I equals 4 amps. 4 amps.